The Bermuda Triangle is a triangular area with its vertices at Miami, Florida, San Juan, Puerto Rico, and Bermuda. The Bermuda Triangle is notorious for the many planes and ships that have entered it and never returned. The Bermuda Triangle has caused 924 deaths, and only 25 people from those accidents came out alive. In this video, we are going to calculate the side lengths and area of the Bermuda Triangle, then find another triplet of cities, which create another triangle with the same side lengths and area as the Bermuda Triangle. Using Google Maps, we find that the distance from Miami to Bermuda is 1,035 miles, the distance from Bermuda to San Juan is 960 miles, and the distance from San Juan to Miami is 1,031 miles. Next, we have to find the area of the Bermuda Triangle. We can do this by using Heron's formula. Using Heron's formula, we get that the area of the Bermuda Triangle is 439,056 miles squared. Now, we need to find our set of 3 cities. To do this, we could guess a set of 3 cities until we find a working set, but that is very inefficient, because first, we would have to find 2 cities that are an equal distance away from each other as 2 of the 3 places in the Bermuda Triangle. After finding these 2 cities, we would have to find a 3rd city, which will create a triangle congruent to the Bermuda Triangle. So, I came up with a different way to find my set of 3 cities. Instead of finding a congruent triangle using only side lengths, I would also use one angle. This way, once we found 2 cities that are either close to 1,035, 960, or 1,031 miles away from each other, we can measure an angle using the distance as the base of the angle. Then, we know how far away the 3rd city has to be, and we know the direction in which the 3rd city has to be, unlike with the previous strategy, where we could only make a rough estimate in the direction the 3rd city would be. However, to use my new strategy, I need to know an angle measure of the Bermuda Triangle. You may think that there is no way to find the angle measures of the Bermuda Triangle, but there is. The formula for the area of a triangle is A times B over 2 times sine C, where C is the angle between sides of length A and B. We already know the sides and area of the Bermuda Triangle, so using this information, we can solve for the angles of the Bermuda Triangle. First, we can express the area of the Bermuda Triangle as AB over 2 times sine of gamma. We know that the area of the triangle is 439,056, and that A is equal to 960 and B is equal to 135. So, we have that 1,035 times 960 divided by 2 times sine gamma is equal to 439,056. Simplifying, we get that sine gamma is equal to 439,056 times 2 divided by 1,035 times 960. So, arcsine 439,056 times 2 divided by 1,035 times 960 is equal to gamma. Using a calculator, we get that gamma is equal to 62.1 degrees. Using the same strategy to find alpha and beta, we get that alpha is equal to 55.4 degrees and that beta is equal to 62.5 degrees. So, using a picture of the Bermuda Triangle, I could label the angles as such to reference when I finally went to test my new strategy. Now, I was finally ready to find my 3 cities. I started by finding the cities Warsaw and Taormina, which are the same distance apart as Miami and Bermuda. Looking at my diagram, I saw that the 2 angles on the distance from Miami to Bermuda are 62.1 degrees and 55.4 degrees. I chose to use the 62.1 degree angle. I measured 62.1 degrees clockwise of the distance from Warsaw to Taormina. Because I used the 62.1 degree angle, the 2 distances the angle is in between must be 1,035 miles and 960 miles, so my 3rd city must be 960 miles away from Warsaw. Finally, I put all this information together. and found my third city, Le Mans. In just a couple minutes, I had found my 3 cities: Warsaw, Taormina, and Le Mans. Here is a picture of the Bermuda Triangle and my triangle on the same map. As you can see, both triangles are the same.